Okay, so number 4 says find the values of the trigonometric functions from the information given. Again, we have two pieces that we are going to analyze. So secant is the reciprocal of cosine. And we know cosine is talking about x values. Okay? So if my x values are a positive 7, okay? Right, there's a positive 7. That means my x values are going to be to the right of the y-axis. So a positive x value will look something like quadrant 1 or quadrant 4 is where my reference triangle is going to lie. Again, I'm doing the QRST method right now. The next part is we know that the sine, otherwise aka the y value, is negative. Okay? So if the y value is negative, we know it's going to be quadrants 3 and 4. And you're looking for the place where these two conditions overlap, which is going to be right here in quadrant 4. Okay, so let's look at cosine, or secant. Secant is the flip of cosine, which you can, instead of saying x over r, you can say r over x. And if it's equal to 7, it's like the same as saying it's equal to 7 over 1, where r is 7, and where the x is a positive 1. From here, we're going to use Pythagorean theorem, and we're going to say 7 squared minus 1 squared, and we're going to take the square root because we're coming from the hypotenuse to find the other leg. Okay, so you could say like this is x, if you will. So you have 49 minus 1, it's going to be 48. So it's going to be the square root of 48 is this side right here. So the square root of 48. Yes, we can simplify the square root of 48 by saying I could divide 48 by 4, which would be 12. So that whenever I take it out, this square root of 4 will come out as a 2, and 12 will be left over as far as being inside. And yes, some of you are already seeing that you can simplify this even further to 4 and 3. Where this 4 will come out, and the square root of that is another 2, which when it comes out as another 2, you're going to multiply what's already out there to get 4 root 3. So 4 root 3 is the simplified version of 48. One more thing that I can show you is if I wanted to do 16 times 3 to represent 48, you could have also seen that the square root of 16 would have come out as a 4, so you could have gotten to the answer even faster. Okay, so now that I have 1, 7, and 4 root 3, I'm now able to find the rest of these trigonometric functions. So sine is y over r, otherwise my y value of 4 root 3 over the r value of 7. The 4 and 7 do not reduce, so you're pretty much done. There's your answer for sine of theta. Because again, remember, theta is that angle from the origin. So the cosine is going to be the x value over r, which in this case is going to be a positive 1/7. Because remember, r is always positive, always. The tangent is a y over x, and I'm looking at the y value of 4 root 3 over the x value of 1. You can write 1, but it isn't needed, so you could just write 4 root 3. Cosecant is the flip of sine. So we're going to reciprocate that right now to 7 over 4 root 3, and then we're going to multiply it by a form of 1, just root 3 over 3, not including the 4, because all we're aiming at is canceling out this root 3. So we get 4 times 3, 7 root 3 in the numerator, and nothing cancels as far as the 7 with 4 or 7 with 3. So we're going to go ahead and multiply it out and get 7 root 3 over 12. This is my simplified answer. And then last but not least, our cotangent. So I'm realizing right now that I'm overlooking this right here. And a lot of you may do this on the test. I'm overlooking the fact that my y value is actually a negative. So in my reference triangle, and this is a good good teaching experience, if you will. This 4 root 3 is actually going to be a negative 4 root 3 because of the fact that it's below the x-axis, which is going to be a negative y value. So everywhere where I was working with this negative 4 root 3, I need to put it here. I need to put it, it was a negative y over a positive x, so it should be a negative 4 root 3. And then of course this cosecant is going to be negative as well, so it's a negative 7, because remember the cosecant is the flip of sine, and that was already negative. And then finally I can finish off with the cotangent, which is going to be the reciprocal of my cotangent. So I could do negative x over y, or I can just take my answer, which is negative 4 root 3 over an understood 1, and take the reciprocal. So I get negative 1 over 4 root 3, and yes, we will we will rationalize the denominator one more time to get a negative root 3 over 4 times 3, otherwise known as 12. So we have the following. Our first answer was negative 4 root 3 over 7, the positive 1/7, negative 4 root 3, negative 7 root 3 over 12, and negative root 3 over 12.